Hi, I'm Ashley.
I'm Brianna.
And I'm Julia.
So for our final project, we decided to look at the highest Hollywood grossing movies. We found our data set from the website Kaggle, and here's a little bit about our data set.
Summary. Our data set, it consists of the highest Hollywood grossing movies, and it provides information about the top 917 movies as of January 10th, 2022. This information retrieved for the data set was collected from IMDb and Rotten Tomatoes, which provides insight into the revenue it generated domestically and internationally. Our motivation for choosing this data set offered many opportunities to explore by comparing averages of revenue to various variables through data scraping. This includes comparing revenue between genres and distributors to find which generated the greatest and least amount in sales, therefore allowing us to extract meaningful correlations to hypothesize the causation behind the factors that were most successful. To describe the relevant variables of the original data set, there were 919 observations. There were numeric variables consisting of domestic sales, international sales, world sales, release date, and movie runtime. Our categorical variables included title, movie info, distributor, genre, and license. And then we converted movie runtime to a numeric variable in our updated data set. So particular attention will be paid to the world sales variable to draw correlations between the genres, distributors, and titles that generated the most revenue. The sales variables are depicted in dollars, with the world sales column representing the total revenue, domestic and internationally. The genre variable includes a list of corresponding genres for each title, and then lastly, the movie info variable is of no value to our data scraping and will therefore be removed. So here is a couple graphs that we made to just describe the relevant variables. The first graph in the top left corner shows the distributors of the top Hollywood movies, and as you can see, the top distributors are Warner Bros. And then Walt Disney Studios, because they have the most movies that appear on the top Hollywood movies list. And then next, we have the genres of the top 10 movies. So this is just shows which genres made the top 10, which ones were most popular. And then the last graph shows different license that appeared in the top movies data set.
We asked 4 questions: which movie had the greatest sales, which genre had the greatest sales, which distributor had the greatest sales, and what is the average sales of each distributor. And in terms of data cleaning, we added +1 to the X column in order to have the movies ranked in order starting from 1. And then we added a column identifying the movies that are appropriate for kids for our logistic regression. And then we added a column showing only the month of the movie's release date. And then we changed runtime to a numeric variable by removing minutes and hours and converting the hours to minutes. And then we removed the movie info column completely because it was kind of irrelevant. And then we renamed the columns for so they were easier to understand. And then we added we removed all the NAs from our data set too. And then that is just our data set after it was fixed.
To continue our data preparation and summary part of the project, we decided to create some two-way variable tables, also known as tibbles, to compare our categorical and numeric variables. So some of the variables that we compared were total sales per genre, total sales per distributor, summary of total sales, mean of sales per distributor, and total sales per title. And really, we created these tables to help us answer the 4 questions that we sought out to answer at the beginning of the project. So if you don't remember those, we asked which movie had the greatest sales, which genre had the greatest sales, which distributor had the greatest sales, and what is the average sales of each distributor. And this was basically some of the important questions that we drove for our data set. So in order to answer those questions, you can see that each one of these two-way tables corresponds to one of those questions. And the reason why we took the summary of total sales was so that we could gain insight into different central tendencies of our data, such as the median and the mean. And you can see on the next slide that the answers to our questions, which movie had the highest total world sales, was Avatar, and which distributor has the highest mean sales was 20th Century Studios. And you can see from the other tables as well that the distributor with the highest total sales was actually 20th Century Fox, and the genre was action, adventure, fantasy, sci-fi, and I already answered these two questions. So yeah, that's basically what we used for our data preparation and summary.
Beginning with the data visualization portion of our data set, it is important that we extract meaningful correlations and information through the production of different graphs. First, looking at the first bar graph in the top right corner, you can see that our code uses the GeoMBar function in RStudio to produce a graph of the distributors and ratings. First, I want to bring your attention to the NA column of the movie rating axis. These were kept in purposely because they represent the unrated movies, and they don't stand for non-applicable. And now, beginning the analysis of this graph, the first piece of information that stands out the most is the number of movies with a PG-13 license in our data set. This means that PG-13 movies are more likely to be successful and appear on the highest Hollywood grossing movies data set. It's also evident from the lack of G-rated movies in the data set that creating a movie with a license above G will more likely generate more money and have a higher chance of occurring in the top movies data set. Then, looking at the breakdown of distributors per movie license, you can see that Warner Bros. And Walt Disney Studios, which is signified by the pink at the bottom of the columns, account for the majority of licenses or movies occurring in the data set. Additionally, you can also see that Walt Disney Studios produced the most successful G-rated movies, which makes sense because they're known for their successful children's movies. And lastly, it is evident that the PG-13 and NA licenses have similar proportions per distributor, which is shown here. This is the PG-13, and then here's the NA. Now moving on to the second graph, the histogram. This graph is paramount in visualizing data distribution. As you can see, the frequency of world sales quickly declines as world sales increases, which signifies a negative relationship. Now bringing your attention to the code we use for the graph, we use 30 bins by taking the square root of the total number of data points. Now next, continuing our data visualization, we next have a side-by-side box plot. This is useful for our data analysis because it compares fundamental information such as the median values and range. It also is successful in providing a summary and analysis of the data. Our box plot in particular presents a relationship between movie ranking and distributor, with the red points representing outliers. First, we must acknowledge the placement of the majority of the outliers. Based on this placement, distributors are more likely to produce a movie that received an exponentially low rating than produce a movie with a ranking that is more successful. This is evident when noticing that the majority of the outliers appear at the top of the graph, signifying a lower rank. And movies with a high ranking can be seen at the bottom of the box plot here. Additionally, the box plot presents which distributors produced movies with the greatest variation of movie license. For example, Walt Disney Studio seems to own the most movies with varying licenses that appear in the data set. They also produce the most outliers for movies with a lower ranking because they are known for their top ranking successful movies. This is also similar with Warner Bros., as they also have a large variation in licenses for the movies they produce. This correlation suggests that the most successful distributors produce movies with a range of licenses, which targets different people and their interests. Now moving on to the scatter plot, this visualization is imperative to show the extent of correlation between two variables. In our case, we assessed the relationship between domestic sales and movie ranking and found a clear exponential relationship between the two. As the ranking of the movie lessens, the domestic sales decrease significantly, therefore showing that movies with a higher rank will produce more domestic sales. Lastly, the dot color also signifies if the movie is appropriate or not for children. Red dots represent movies with a PG rating or lower, deeming them appropriate for kids, and blue dots represent movies with a rating of PG-13 and above, deeming them not appropriate for kids. There seems to be a greater amount of dots signifying movies that are not appropriate for kids on the top movies dataset. Further, movies with the highest domestic sales are shown to not be appropriate for kids, which is signified by the blue dots.
So this is our side-by-side box plot, and it shows 2 categorical variables and 1 numeric, and it's the month versus world sales. And the box plot shows the world sales along with the month that the movie was released, and the PG-13 movies in April had the largest interquartile range. And the movies seem to be released in greater quantity during the warmer months of May through July during the holiday season from October through December. And December has the most outliers for movies with exceeding world sales.
So for the special map portion of our project, we decided to create a heat map. And a heat map is a graphical representation of data that uses a system of color coding, which you can see off to the right here, to represent different values. In this case, we use the color to represent world sales. So for this heat map in particular, it demonstrates the relationship between movie rating, release date month, and the world sales. And some inferences that we made from the data was that it suggests that movies released in March and June rated G had the highest world sales, which you can see by this color green. Also, PG movies released in November and December had higher world sales, and PG-13 movies in February and September, and finally R movies in June, September, and November. Another inference that you can make from this graph is that the values depicted on the graph, the world sales, the total, like the highest is around 1 billion, which you can see from the blue and green colors. It doesn't really get up to the yellow and the red, as you can see. For the next part of our project, we had to create a simple linear model for our dataset. And a simple linear model is a way of describing a response variable in terms of a linear correlation and predictor variables. In other words, we created a linear regression model to evaluate correlations within our data. We evaluated the correlation between domestic sales and international sales. And the formula that we got was domestic sales equals 0.03756 times international sales plus 8.085 times 10 to the 7th. And basically what that means is that for every $1 increase in international sales, there is a 0.03756 increase in domestic sales. So the predictor variables that we used to basically get this formula in our summary off to the right were international sales equal 86,000, 650,000, 8,805,000, and 2 billion. And for example, with international sales equals 86,000, we predicted that domestic sales would be 80,684,705. And if you look over to the right, we have our summary that we found from RStudio. And this really tells us a lot of important things. For example, the multiple R squared value is 0.6336. And this tells us that there's 63.3% variability that can be accounted for by our model. And yeah, that's our simple linear regression model. Next.
So here we have our logistic regression model, and we tried to see if the variables seen below could predict if the movie was appropriate for kids or not. And so when we exponentiated the coefficient for movie ranking, domestic sales, international sales, and runtime in minutes, we got values that were basically equal to 1. And on all of the variables, movie ranking, domestic sales, international sales, and runtime in minutes, we found the odds are almost equal to 1. And this means that there is no relationship between movie ranking, domestic sales, international sales, and runtime with if the movie's appropriate for kids or not?
So for the final part of our project, we looked at the classification of our data set. And in order to do this, we used the K-nearest neighbor model. Now, the K-nearest neighbor model uses neighbors of data to predict what other data will be. So in other words, the K-nearest neighbor model tries to predict the correct class or category for the test data by calculating the distance between the test data and the training points. To put it more simply, if you are like your neighbors, you are one of them. So for this model, we used the international sales, domestic sales, and movie ranking in order to predict the movie runtime. And we looked at the nearest odd number of neighbors to create a model. Our KNN model used the 9 nearest neighbor regression model. And basically the way that we can interpret our results is that if the movie ranking is 38, the domestic sales are 30 billion and the international sales are 4 billion. Our model predicts the movie will be 147.4 minutes long. And that's our project. Thank you for listening. Have a great day.